All right, let's talk about linear equations. Now, I know what you might be thinking. Algebra. Just another long list of rules you have to memorize, right? Well, what if I told you we could throw that idea out the window and focus on just one single powerful concept? Let's dive in.
I mean, does this question hit home for you? Because for so many people, learning math felt exactly like this, like trying to follow a recipe with 100 steps without ever getting to taste the food. But trust me, it's not about memorizing rules, it's about understanding the big idea. So let's just completely reframe this whole thing. Forget about all those properties and theorems for a second. At its heart, solving an equation is all about one thing: balance. Seriously, that's it. Everything, and I mean everything we're about to talk about, comes right back to that simple idea. Okay, so let's get right into it. The equation balancing act. To understand this, we need to think of every equation you'll ever see as a perfectly balanced scale. Think about it. An equation is basically a promise. It's a statement that the stuff on the left side has the exact same value, the same weight, as the stuff on the right side. They are in perfect equilibrium. And because they're balanced, they're super sensitive. So if our equation is this perfectly balanced scale, how do we actually work with it without sending everything crashing to the floor? Well, that brings us to what I like to call the golden rule of balance. This is maybe the most important rule in all of algebra. Okay, I know. That sounds super technical and textbooky, right? Properties of equality. But don't worry about the jargon. What this is really telling us is something incredibly simple and intuitive. Let me translate this using our scale.
And there you have it. That's the whole game right there. It's that simple. If you add a 5-pound weight to the left side, you've got to add a 5-pound weight to the right to keep it level. If you decide to take half of the items off of one side, you have to take half off the other. This one rule ensures our scale stays balanced, always.
So why do we even need this golden rule? Well, we use it to solve a puzzle. See, most equations have a little mystery box in them, which we call x. Our job is to figure out what's inside that box, what x is worth, all while keeping our scale perfectly level.
Let's see this rule in action. We've got our balanced scale, 2x plus 3 on one side, 5x plus 3 on the other. First step, let's get our x's together. We'll take 2x away from both sides. The scale stays balanced, and now we have 3 equals 3x plus 3. Simple enough. Step 2, let's get rid of those extra 3's by taking one from each side. Still balanced, and we're left with a very simple statement. 0 equals 3x. Well, for that to be true, x has to be 0. And just like that, puzzle solved.
Now, usually you'll find that one perfect answer, that one value for x that makes everything work. But, and this is where it gets really interesting, sometimes algebra throws you a curveball. Sometimes the whole idea of balance can lead to some pretty weird results.
Right? What happens when you follow that golden rule perfectly? You do everything right, but the answer you get at the end just makes no sense at all. This is where we uncover the other two possibilities for what an equation can be.
These two special cases are called infinite solutions and no solution. Think of it this way. With infinite solutions, the scale is so perfectly designed that it's always balanced no matter what. With no solution, the scale is just plain broken. It's built wrong. It can never be balanced. Let's see what each one looks like.
Okay, here's our first strange case. On the left side, we have 2x plus 6. On the right, we have 2 times the quantity x plus 3. Now, they look different at first glance, don't they? But let's just tidy up that right side a little bit.
And will you look at that? It simplifies to 2x plus 6 equals 2x plus 6. The two sides are absolutely identical. We're not even solving a puzzle anymore. The equation is just telling us that a thing is equal to itself.
This is what we mean by infinite solutions. You can plug any number in the universe in for x. 5, 27, negative a billion. It doesn't matter. The equation will always be true because you're just ending up with a statement like 16 equals 16. The scale is balanced by its very design.
All right, now for the total opposite scenario. Let's check out this equation. We've got 4x plus 2 on one side and 4x plus 5 on the other. Okay, let's try to find x using our golden rule.
So we apply the golden rule. We subtract 4x from both sides to try and get x by itself. But wait, look what happens. The x just vanishes from both sides completely, and we're left with the totally impossible statement that 2 is equal to 5, which it's not. And this is what we call no solution. The equation was a trick from the start. It was a fundamentally broken, unbalanced scale. No matter what value you could possibly dream up for x, the right side is always going to be 3 more than the left. The statement can never be true, so there is no solution. The scale can't be balanced.
So we've spent all this time talking about perfect balance. But what if we actually want to talk about a scale that's unbalanced on purpose? Well, that's exactly where inequalities come into play.
You see, an inequality is just a statement about an unbalanced scale. It's designed to tell us that one side is definitely, for sure, heavier or lighter than the other. So instead of that good old equals sign, we use symbols like greater than or less than to describe exactly how it's unbalanced.
And you can even take it a step further by joining two of these unbalanced statements together. A compound inequality lets you set a range. It's like saying, okay, I know this value is heavier than 5 pounds, and it's also lighter than 20 pounds. It's a way of putting some boundaries on the imbalance.
So let's step back. We've gone from thinking of algebra as a giant, scary rulebook to seeing it for what it is, a really elegant toolkit for understanding the idea of balance.
So if you take anything away from this, let it be these 3 things. 1, every single equation is just a balancing act. 2, your most powerful tool is that golden rule. What you do to one side, you must always do to the other. And 3, following that rule will always reveal the truth about the equation, whether it has that one perfect solution, an infinite number of them, or none at all.
You know, this idea of balance, it's not just in math class. You see it in physics, in chemistry, in economics, even in just trying to figure out a budget. By really understanding these core principles, you've got a whole new way of looking at the world around you. So the only question left is, what puzzles are you going to solve next?